So we're talking about the row manipulator. Yeah, right here. This is from 1024. That should be all it takes in order to get lines line 53 to work, or 52 or 53 is it's shown there. Yeah, go ahead, take a look at these notes and on the 24th and look compared to your code. 1024, 2018, 1024. Any other questions? Because that's all I'm here for, is to help you finish. Anyone finished, or anyone close to finished, or anyone feel like they're making progress? That's a big step.
I'm wondering, just like we have to write like our own stand string for like take reading in a float number, are we supposed to also write our own stand string to read in an integer?
Well, what do you mean to read in a float number?
Just like when you do that SS chevron and then 3.14, that's like a float number, right?
Right. You don't have to write any code for that to work, though.
You don't have to?
No, because that's all, you're inheriting all that, right? If you look at, so there are a number of clues. So if I type OStream, all right. So the first thing to note is it's a public, this is the base class, the OStream, right? It's a public member function, so that is a clue right there that you never override public member functions. They're not virtual. And if you read about what these do, let's see. All right, let me zoom in a little bit. So it's speaking to all of these here. I mean, pick any of them. Pick the float, or the double, right? That one. Generates a sequence of characters, meaning a 3, a point, a 1, and a 4, with the representation of the value. So those 4 characters are the representation of that float in memory, those 8 bytes representing that float. Properly formatted, blah, blah, blah. And inserts them into the output stream. Here, this is what I need. Internally, the function accesses the output sequence by first, hang on. All right. Then it calls put to perform both the formatting and the insertion operations. So let's look at put. So this is iterating. Talks a lot about formatting because you can specify the precision of output and things like that for floats. So that's what a lot of this talk is about, is that it's figuring all that out. Let me see if I can find the money line here. All right, here it says internally it calls do put. Let's see if do put tells us. I think we're just there. It's sending me in a circle. Is this numput? Oh, yeah, let me look at these arguments. Iterator, character type. So let's see with the iterator, it's I think that this is a little hard to parse, but I think this is what happens is there's some iterator provided. This iterator is actually pointing to the buffer or interacts with the buffer. It says points to the first character where the representation is stored. I want to say that that's it, but I'm not fully confident. Let's see. Ends up calling put, so let me rewind here a little bit. Oh yeah, yeah. All right. So I was reading the wrong bit. No, I'm not reading the wrong bit. Let's see. That is the stream. Well, ultimately, the numeric put is ultimately calling put, and put is what interacts with the stream buffer. So you are creating your own subclass of the stream buffer. You're calling it stamp buff, and it's managing an array of characters, and it's already got functions that will put things into that array. So these operators convert these various types into a sequence of characters, and then it's talking to your buffer through that pointer saying put, and at some point it's going to overflow, and then it'll call either overflow or sync, and then that's when your code kicks in. So you see, you don't have to write anything to deal with any of these types. All that code's written. All this code will automatically put things into your stream, into your stamp buff. That's why you don't have to write it all. All that's done for you. You just all you have to do is you have to write what happens when your buffer fills up or what happens when someone asks to synchronize your buffer. And in both cases, you just iterate through stamping out. Set die stamp, set die stamp. What else?
Is the sync and the overflow seem really similar?
They are really similar.
Can you just use one?
Yeah, that's often what people do is they write sync and then their overflow function calls sync. The one thing you don't want to forget about is overflow passes in the character it was unable to write that caused the overflow.
Yeah, I was trying to figure out the best way to do that.
I'd call sync and then I would manually. You know, there are a number of ways you do it. I've seen people. They call sync and then they manually set die and stamp that last character. And then I've seen other people just make like that the first Actually, what they normally do is they create a buffer of, say, 20, and then when they do set P, they say it's only 19.
Yeah.
And then that means that there's an extra character there unfilled, and the first thing they do is plop it in there.
Yeah.
They call put or something and plop it in there, and then they just loop through the whole thing.
So is that what you were showing earlier on the little map here? The little loop that's on the end of O stream in the diagram that you had before.
Do you have a date?
Yeah,
October
October 22nd.
22nd.
One of the ones you didn't post.
Oh, I didn't post it?
No. It was the one that showed the whole.
Oh, is that the exercise, the in-class thing?
Yeah, the in-class one.
Oh, all right.
Actually, I guess you started that on the week before that.
That'd be this image here. This one?
Yeah, that's the one.
So what are you looking at? This?
Yeah, the convert to characters, right? So
This is what we were talking about at the very beginning of class. You are inheriting all of this.
Right.
This is the operator for floats, bools, integers, doubles, right? All that stuff you just inherit, and this is just showing you what it does. And the reason I had you go through this is so that you come to the conclusion that all this stuff you're inheriting is putting each character one at a time into your buffer.
Right. Okay. Yeah. So we don't necessarily need to call the S put C
No, you don't.
themselves, right? Because
That's all inherited. You don't do anything. All you have to do is make sure you have a buffer so S put C knows where to put it. The analogy is the library project where you have a function that loops through pointers asking each one to display when you display results, right? And you don't have to, there's not, all that work's been done for you, and if you have another class, a DVD class, you just create a display function for it and it'll get called automatically. You don't have to make it get called. So this will fill up automatically. What else?
run through the algorithm, like pseudocode or whatever graphically? So
Well,
I
let's.
was kind of getting a little lost on some of these, the order of all this stuff.
Well, I guess the thing to talk about is what are your responsibilities. So these are notes from the 22nd. This is showing stuff that already exists. This is showing the class you have to write. Most of your code will belong in this class. This is stamp buff, which inherits from that code up here. You have to write a constructor. That constructor needs to allocate an array of characters. You probably have private data. Let's see if I put it in this. No, I didn't put it in there. You probably have, a character pointer as private data to store that character array. Yeah.
How big should we be allocating the array to be?
If you look at the rubric, it's supposed to be robust against any reasonable size. So I would take, I would try the number of rows, or excuse me, the number of columns and divide by 2, and then try the number of columns divided by 3, and then try the number of columns, right? Just pick a size and then just change it up after you get your stuff working. So this is just, what's this, 2 lines of code, a new statement to allocate your character array, and then you call set P, which sets up all the pointers so that this stuff works correctly. Right? Calling set P gets these all in place.
Right.
So that's it.
So yeah, and you're just passing. So set P, that's doing all the work for us, right? We're just giving it, hey, this is the beginning of my buffer, and that's the end.
Yep, yep.
And then,
And then you need to release it in the destructor, and then you have to write overflow and sync. And it's nothing more than looping on this. Set die and stamp, set die and stamp, set die and stamp. You have to write a stamped stream class, but as I've said before, that's almost no code at all. Its primary purpose is to create a stamp buffer object and assign its address to using, it can be a no-streams constructor. I provided code for that somewhere.
yeah.
And then there's the manipulators. There's writing an end row manipulator that both takes and returns a stream pointer, and there's the row class, which we talked about last time or the time before. So I think a good approach is to see if you can create, you can create this without doing much. Create kind of a stub for this class, create a stub for stamp stream, which inherits from OStream. Get those to compile and then start adding things to them. You could probably deal with row and end row last.
So the interface for that we're building, this is really just going to be these different classes that the programmer would use in his own main file, or whatever, to
Once your code is in place, then that code you see in the PDF that has "thanks for all the fish," that weird text, right?
Yeah.
So programmers will take your code and be able to do those kinds of things. We'll be able to use the stamping press as if it were C out.
Right. So we're not building like asking the user for their input.
Nope. Nope.
Okay.
You'll just, most people use that test main that I have in the PDF to test out their code, which was bundled with the tarball. Any others? If there are no big questions, I'm happy to turn off the recording and answer individual questions if you have any individual things or want me to look at code or whatever. So for the sake of people listening to this, so they don't have to listen to a ton of silence, I'll stop it.